So this is a very short lesson about biconditionals. So you write a biconditional if both the conditional and the converse are true. For example, well, let me go through the definition first. A biconditional is when you join two parts of each conditional with if and only if. So, example 1, each conditional statement below is true, write its converse, and if the converse is also true, combine the statements as a biconditional. So, the first one, the conditional, P implies Q. If 3 points are collinear, then they lie on the same line. The converse, Q implies P, if 3 points lie on the same line, then they are collinear. Is that true or false? Well, that is true. So we can write this as a biconditional. 3 points are collinear if and only if they lie on the same line. So you replace the if and the then with if and only if. You have to be sure that when you write your biconditional, you write your biconditional as the original conditional statement, meaning that the hypothesis of the conditional is the first part of the biconditional. Okay? All right, let's look at the second example. If x equals 5, then x plus 15 equals 20. That is true. So we can say x equals 5 if and only if x plus 15 equals 20. So the converse of this one, I don't think I said that, would be if x plus 15 equals 20, if x plus 15 equals 20, then x equals 5. So sometimes you're given a biconditional, like this example right here, and you have to separate it into two parts. You have to write it as a conditional, P implies Q, and also write it as the converse, Q implies P. So it says write the two statements that form this biconditional. So the first statement would be if a number is divisible by 3, then the sum of the digits are divisible by 3. The converse of that would be if the sum of a number's digits are divisible by 3, then the number is divisible by 3. Okay? If If you're not listening to this video and you're hoping that you're going to be able to read my chicken scratch, that's not going to work for you. You have to absolutely make sure that you listen to the video. Your last example, a number is prime if and only if it has two distinct factors, 1 and itself. The conditional would say if a number is prime, then it has only two distinct factors, 1 and itself. The converse, if a number has only two distinct factors, 1 and itself, then it is prime. So let's talk about a good definition. It uses clearly understood terms. They're precise, and they can be reversible. They can be written into a true biconditional. So your assignment for today is actually a quizzes. It has 23 questions on it, and after you take your quizzes assignment, you will be required to submit your score. So do your best.